Now this drawing is the week 7 project. Now that's your midterm mark at that point. So here we have all the calculations identified to what I've selected. But before I get to that point, to draw out all the details of each of the zones, how it looks in section. So if I cut through this and look at it from the side, what do I actually see? Well, up through the center, I would see the upper deck sitting on top of a beam, the lower deck here sitting into the side of this beam, and then the lower deck sitting on top of this beam, along with the distances I've calculated here, and then my calculations would work from there. So we're going to run through an example just to show you how this all works. So in this next section, I'm going to show you how we evaluate the actual beam and the deck framing or the floor framing based on how we've conceptualized this space. As I mentioned to you earlier, some information is really important, like the distances, but let's draw this in section. And there's going to be a bit of a challenge here only because I'm using a drawing pad here for the purposes of this project. So we have the house itself. There's the house. I'm sorry for how crooked it looks. But then I have the deck that comes off of it. And there's the deck. That's not a bad line. And here's the deck. There's the edge of the deck. And I'm going to draw the rim board. So that is this board edge right along here. Now below that, I've got the beam. So I'm going to try to match some of the colors so it becomes familiar with you when you go to actually draw it again or to review this actual lesson. Now the beam itself hasn't been calculated, so I have no idea what size that is. I'm just going to draw it like that. And typically, sorry about that, we draw an X. I'm having a bit of a challenge here. Let me just undo some of this work that I've created here. So I'm going to draw a box here. There we go. That's the actual beam. And once again, I don't know the size of it, but I know that the center line of this, there's the center line, is 2 feet from the edge. So there's my overhang there. The building itself, or how it's attached to the building, we're not going to get involved in right now. I don't know, but I do know I'm going to need a ledger. And there is my ledger. So what have I got drawn here? How does this actually look? I've got a couple of different images here just to show you what I've drawn. There we go. There's the ledger board that's attached to the house. There are the joists that are going to hang from it. So that's essentially what we've drawn here. There's the ledger board and there's the joist, and then it sits on top of the beam. So we're going to go through our calculations. How do we actually determine this? Okay. Now I typically draw all my dimensions in red just so that it's noted in a specific way. It's a structural element. Sorry, I'm going to undo that line. It's a structural element. So there's the center line. And I also have this measurement here. So from there to there and to there, I have basically all the dimensions I need. So I've got a dimension here, here, and here. So this first number here is the span. That's the span of the joist. So that number comes off here, 11 foot 4.5 inches. So this here span is 11 foot 4.5 inches. Okay, there we go. And this over here is 2 feet. Now, as I mentioned before, the actual joist is 13 foot 4.5, but the span of the joist is 11 foot 4.5. That's important because we're actually going to calculate that size of the joist. Now, you're going to have to go back to what we had earlier, all our deck charts, our joist charts. So if I go into here, I don't know if you remember, but this is a good review. We're going to take this and we're going to find out how we actually calculate this information. So remember how this gets used. So this is our floor joist that we're working with here. And when I take a look at this particular chart, what I'm trying to actually do is focus in on some of the information that we talked about earlier. Here we go. So always we're looking at this column first, 16-inch on center, and then the different methods of keeping that framing in place. My distance is 11 foot 4.5. So when I go to this chart, this says, oops, I went to the wrong setting here. 11 foot 4.5. That's 11 foot. So I want to go to the next one, which is 12 foot 11. Then if I go to anything with strapping, this one meets it, 11 foot 8. It's tight, but it definitely meets that requirement. And then bridging and strapping, once again, 11 foot 4.5. So what's the difference? I can go with 2x8s if I use bridging, if I use strapping and bridging, or I'd have to go with a 2x10 if I don't use anything to meet that distance. So that was the information we had written down the other day. That was really important. So in this particular table, and I'm sorry, my computer isn't keeping up with all the information I'm delivering here. So if I take a look at my project here, my actual joist itself, there we go, the joist, its span is 11 foot 4.5. So according to the OBC, I can go with 3 different types. I can go with 2x10s at 16 inches on center, and that is a maximum, gives me a maximum of 12 foot 11 inches. So that's my maximum joist span, or the maximum. So if that beam gets moved, it could be moved up to that distance away from the edge of the wall, and I'm still safe. My other option is to go 2x8s at 16, and again, we like to keep it 16 only because that is the most efficient way of selecting joist and framing it out, and that will go 11 foot 8. Now that's a bit tight, but 4 inches is pretty good. And this is with strapping, or I'm sorry, with bridging. And then we can also go 2x8s at 16 inches on center. Now, why am I putting this one down? Again, if I just have to move that beam over slightly, I have another 4 inches of play here. Actually, I've got 6 inches of play here, and that's with bridging plus strapping. So it all comes down to this beam and what happens on the site conditions. If that beam can't be exactly where it is and it needs to move either way, then we're still safe. Now remember, that beam, we're measuring from the center line. If that's a 3-ply beam or 3 2x-whatevers, that's really 4.5 inches wide. So I still have another 2.25 inches of gap that I haven't accounted for in these numbers. So we're really trying to safeguard our margins whenever we're doing these types of calculations. Now, what about the beam itself? What is it carrying in terms of weight? Well, I do know, for instance, based on that span, that I've got a supported length here of half of that. 11 feet, half of 11 feet is 5 foot 6. Half of 4.5 inches is 2.25. So that would be 5 foot 8 and 1/4 inch. So that means this is 5 foot 8 and 1/4 inch plus the 2 feet overhang. So this beam is actually carrying 7 feet 8 1/4 inches. That's the supported length of that beam. So how does that help us? Well, let's take a look at the table. So now we got to go to the other table, which is this one here. And once again, I apologize, just that my computer's having a tough time keeping up with me here. There we go. Remember, on this table, we don't use structural select. We use SPF 1 or 2. The supported length I have on this particular example here is 7 foot 8 1/4. That's this number here, and look at that, 7 foot 10. That's the very first one that we have here. So I'm just going to highlight that number for this project. So what do these numbers refer to? They refer to how much spacing I can have between columns for that beam. That is this distance for beam number 1 from this column to that column. Now notice what I've got here. It's about 6 foot, it looks like 3 1/8. I've got way more beam than I require. Even the least sized beam, which is 3 2x8s. So let me mark that off here. 3 2x8s gives me a column to column distance of 10 feet. I've got lots of room for this particular project, but I mean, take a look at it. It's not carrying a lot of weight. It's not doing a lot, so that makes perfect sense. And that's what you have to also do, is evaluate your project based on what makes sense. So in this particular case, we can go and clearly state that for beam number 1, and that's the way we've drawn this on the table here. Beam number 1, the supported length equals 7 feet 8 1/4 inches. So right away when we look at the OBC, it says that for a supported length of 7 foot 10 inches, we can use basically 3 2x8s, and those 3 2x8s give us a maximum supported length of 10 feet 0 inches. And remember, we always put the Ontario Building Code requirements in brackets so that we can see we need 7 foot 10, we got 10 feet, we got lots of room. So that is beam number 1 is 3 2x8s. Joists for zone number 1 is 2x8s at 16 inches on center. And we don't want to use 3x10s, but 2x10s, but we really need to look at the whole project in order to evaluate this. So this is all titled Zone 1. And that's what you're going to do for each of the different zones. Now, as it would happen in this particular case, this is the easiest zone, and it's the first one I wanted to go through with you on this project.